Welcome to Visual Dust Hazard Analysis, Understanding Threats and Assuring Controls. My name's David Hatch, and with my colleague Michelle Murphy, we've developed a method for evaluating the potential for dust hazards. We've combined experience in conventional process hazard analysis. My own expertise is in Bowties with dust explosion science and maintaining operational integrity. So this approach combines a significant amount of practical experience to address old problems with new ideas. We've known about the issues of dust explosions for literally centuries, whether it's grain or pharmaceuticals or other materials. There's always the potential for uncontrolled ignition and the escalation from the simple fire triangle to go from a conventional fire to a flash fire and ultimately to a dust explosion. So the migration from the fire triangle to the fire pentagon, where you're combining the fuel, some oxidant, some confinement that gives you the overpressure, dispersion, and the ignition source. So dust hazard analysis is not new. The aim is to identify fire and deflagration or explosion hazards, and you must consider both the dust within the process equipment, but also dust in building spaces. So you have deliberate or accidental creation of atmospheres outside the containment. And the methods for identifying, applying standard hazard analysis, again, are well known, well understood. And it starts with an understanding of the material, the physical properties, the safe operating or explosive ranges, consideration of what safeguards you may have and any safeguards you may actually need. So you recognize that dust hazard analyses flow like pretty much every other process hazard analysis. There's start with identifying the hazards, the potential to cause harm, then defining the scenarios where those hazards can be released, where you're losing control or containment, evaluate the safeguards, they could be organizational or technical or both, and then identify and address any shortfalls where you need to implement additional safeguards or improve or enhance existing safeguards. So this is the familiar Swiss cheese model. So we like to think between losing containment and actually suffering or experiencing the consequences or the harm, that we have multiple measures in place, protection measures, whether they be prevention or mitigation. But all these measures, these Swiss cheese slices, are imperfect or fallible. So the potential for an incident passing through these holes increases as we fail to maintain or sustain the integrity of our safeguards or our barriers. So a simple analogy here, we have a Swiss cheese model and we have these mice who are either creating the holes or making the existing holes bigger. And those degradations could be because of equipment failure, human factors, or some external or environmental influences. Taking the Swiss cheese model and evolving it, this is the simple bow tie visualization. At the heart of the bow tie, we have the hazard with the potential to cause harm. That could be hazardous material, hazardous energy, hazardous activities. The top event is the moment when we lose control of that hazard and we suffer or we accommodate the hazard because that makes us money. If we're a brewer or a distiller, we need grain to make the product, but grain has the potential for fire, flush fire, or explosion. So we deal with the hazard. But when we lose control or containment of the hazard, it can lead to consequences, impact on personnel, the environment, the assets, for example. Reading from left to right, the threat, the initiating event, the cause of the top event could be for many reasons. It could be some equipment malfunction, it could be some error, some external issues. So the threat escalates or passes left to right towards the top event, and we have prevention barriers in place that slow or stop that escalation so we don't lose control, we don't have the top event. The flip side, when we've lost control, before we get to the consequences, there may be mitigation measures or barriers that can recover or mitigate those effects. And bow ties are becoming an increasingly popular and powerful technique to assess and communicate process hazards. And best practice for bow ties is in the CCPS Airline Institute bow tie book. Here we have a list of the types of barriers that are employed, and all of these will be employed in the management or control of flammable atmospheres. And each of these has their strengths and weaknesses. Some are more effective than others. Others are more vulnerable because of the nature of their implementation. So if we take an example, this is from the US National Fire Protection Agency document 652. So this Annex B gives an example of a conventional dust hazard analysis. In the standard, it's not represented in this way. It's represented simply as a checklist or kind of what if. So what we've done is visualize that into a graphical format. So we've got this, in this case, it's wood powder, wood chip. So we've got a combustible dust, potential to cause harm. Losing control of that, we've got uncontrolled ignition. Now specifically we're saying uncontrolled ignition because you may want to have controlled ignition because you're burning it for fuel. So the top event is quite specific. Uncontrolled ignition of this combustible dust could lead to injury, could lead to asset damage. The reasons for that, these are effectively the ignition sources. So the combination of the ignition sources with the flammable atmosphere gives us the loss of control or containment. So it could be trapped material, and we prevent that by using metal detectors and spark detectors, or it could be electrostatic sparking, and we address that with bonding and grounding. After the ignition, we try and minimize the impact on personnel by restricting access. Obviously the asset is there all the time, so restricting access isn't an appropriate barrier or mitigation measure. One of the significant benefits of visualizing scenarios and bow ties is you can chain those together. So where you've got propagation from one asset or one plant to another, so if you're losing control or containment in location 1, you're creating burning embers, for example, that can pass down to location 2. So the ignition in location 2 could come from some material passed down from location 1, and that's really easy to represent graphically on the bow ties. So to illustrate this a bit more, we've got this example here where transporting material from a silo through a valve into a bag filter. The bag filter's got an explosion vent. It's feeding by gravity through a rotary valve into a bin. So the more familiar tabular or worksheet approach, a bit like a HAZOP or a conventional PHA, breaking the process or plant into nodes, looking at the potential ignition sources, how those ignition sources could occur, the impact of the fire, flash fire, or explosion, and the safeguards that are in place. Consequence and likelihood scoring gives us a risk ranking, and there's recommendations here to improve or address any shortfalls. What that same analysis would look like in a bow tie is shown here. So we've got our ignition sources, and these are classified according to conventional standards, BS EN 1127, for example. So we've got hot surfaces, which we don't think are credible, electrical apparatus, which again, that's not credible because there's no electrical equipment in the receiver. But we've got two sources of mechanically generated sparks and one source of static electricity. So we have these prevention measures in place that stop these ignition sources combining with this combustible dust to give us an ignition. We've also got mitigation measures that stop after that ignition to reduce the harm on personnel or plant. So we've got explosion venting on the receiver, for example. We've got a rotary valve that prevents the transmission downstream. But we could actually, in this case, that ignition could go back into the silo, and we don't have any measures in place here. So these post-it action notes are advising us we need to take some remedial action. So we've got this simple summary that we believe is a lot easier to understand by less technical people. And it's the less technical people who have to sustain these barriers, who have to look after them. So these are what we believe are some issues with traditional worksheet or spreadsheet dust hazard analyses. You could argue it's the same with conventional HAZOP or PHA, that the way it's structured in columns and rows doesn't give you that appropriate relationship. So possibly you're listing your controls or your safeguards, but they're not listed against the correct cause or ignition source, or you're missing them because they're not properly documented. Important distinction between prevention and mitigation, pre and post ignition or pre and post top event. No real clarity on the connections or the transmission from one node or one asset to another, where you've got an ignition causing smouldering particles that can go downstream or upstream. And ultimately, as a living document, the bow tie can track and indicate the presence and performance of the barriers. So these are available for the lifetime of the facility, whereas worksheets or spreadsheets are only a static snapshot of the assumed or the planned controls on the day of the assessment. So what we believe visual dust hazard analysis using bow tie offers is a clearer sense of what the hazards are in terms of the materials and conditions, the credible causes of uncontrolled ignition, and there's a list of 13 possible ignition sources in BS EN 1127, and also the potential likelihood that those causes or threats will occur. You can also capture the consequences or the effects of the events, and they could be direct effects or indirect effects. So ignition within the equipment, ignition outside the equipment, or ignition in connected equipment. and you can assess that not just on personnel injury, but also asset damage, and if you want, environmental impact, reputational damage, etc. And really at the heart of it are the barriers. So the presence and the performance of the barriers is what keeps you safe. So knowing the type of barrier, the strengths and weaknesses, knowing who's responsible for the barrier, is a really powerful visual reminder that it's these barriers that are sustaining that level of protection, because without them, your uncontrolled ignition sources will lead to these fires, flash fires, and explosions. So we believe that moving from a textual to a graphical format, you're not losing any information, you're gaining a wealth of knowledge. It's exposing dependencies and common mode vulnerabilities, and these could be common mode organizational measures because it's the same person or the same department or same role looking after the barriers, or they're the same type or using the same power supply, or all kind of technical common weaknesses. You can communicate the risks much better to frontline personnel, how they are going to control the flammable atmospheres, how they are going to, through operation and maintenance, sustain those ignition controls or avoid the ignition, because the frontline personnel may not be chemical engineers, they have limited technical awareness, and in many countries you're relying on personnel who have different languages or different cultures. So getting that visual approach across helps give you this lingua franca, this common language to communicate. So we believe that it moves the focus from design or analysis into long-term operation. So you're looking at actual, not assumed barrier presence and performance. And we also believe it simplifies management of change. What is the impact if I delete or degrade a barrier? So I make a permanent change, or I change the setting or override it. How's that going to affect my protection portfolio? So lastly, we want to leave you with this simple message that you can't manage what you don't understand. And the CCPS guidance on risk-based process safety says fundamentally, companies using risk understanding are better able to deal with resultant risks and sustain long-term profitable operations. So at the heart of it is understanding, and we believe the visual approach aids that understanding, and not just aids that understanding, but gives a long-term retention so that personnel are engaged and stay on board with the process safety mission. So thank you very much for watching. We look forward to your questions.